Hi everyone. This is my project, ClearScan AI. Before I start actually showing the slide deck, I kind of just want to give a quick rundown of the structure of the code. Um, so here was our actual training and validation accuracy from the model below right here. This was our ML model that we pretty much trained our Python code to be able to identify between normal and pneumonia pictures. As you can see, as we kept on training, the accuracy and validation accuracy pretty much were on par. We hit a max accuracy of about, I think, 94 or 93%, which was pretty good. And here is the actual app.py, which I named to run the ClearScan AI. It's connected through Flask through a local web page that's right here. This is the web page. I have it right now with the prediction. It's a pneumonia picture that was able to predict pneumonia. Um, and yeah, here's the actual HTML structure of it. And yeah, so this is ClearScan AI. I'm the founder and CEO for Hume. So our mission was we want to empower healthcare providers with pretty much an advanced AI technology that's able to identify pictures of pneumonia and normal X-rays or CT scans, which would help accelerate the analysis of medical imaging. Our problem statement was there's a high demand in X-ray analysis. This will also reduce human error, and radiologists are stretched thin. Impact was that patients have experienced delayed treatment, and also there has been misdiagnosis. So this helps because I mean the accuracy is way better than probably most humans, and obviously it could be increased over time, but a 94% accuracy is still very good. Our solution was we're using an AI machine learning AlexNet. It automates Xray classification. It's reliable and accurate. Our selling points are it's fast, it's accurate, it's very scalable, and it's very user friendly, as you can see from the web page. So the actual medical imaging market is $28 billion dollars with a humongous demand of AI. There is also a humongous telemed and diagnostics AI solution demand. And the competitive edge behind this market is it's designed specifically with X-ray diagnostics and it's also positioned uniquely within its growth market. So the business model behind this is it's a subscription-based model. You can also have enterprise partners. Our potential revenue streams are through licensing fees and data insights. And then in regards to partnerships, it can be healthcare providers, telemedicine platforms, and X-ray equipment manufacturers. Our competitive advantage is we use a proprietary AI model. It's trained specifically on chest X-rays from pneumonia detections. It's a cloud-based deployment, which makes it accessible for people who don't need to have an expensive setup or specialized hardware. Pull it up on your phone or on a computer. It's high precision and recall. It has its architecture offers a strong precision and recalls metrics. It's suitable for high-stake medical settings where accuracy is crucial. So this is kind of just reiterating from before. Right here, you can see that the accuracy was 93, so I was wrong. But between the pneumonia and normal, for some reason, the pneumonia actual precision was much higher than the normal chest X-rays. But we did 20 different tests, and over time, we had started with around maybe 70 to 80%, and then got it up. Our competitive advantage, oh, went the wrong way. So the funding need, we need $1,500 to enhance tech capabilities, run it on servers just so it's cloud-based, and maybe get better testing through bigger data sets. The data set that I used was Kaggle, so it's free. I had about, I think, 6,000 pictures, 3,000 between normal and pneumonia pictures, just to help balance out the actual training to make it more strong. And technical overview. Why AlexNet? AlexNet is proven effective in image classification. It has a deep neural network, convolutional and pooling layers, allowing to capture intricate details. The architecture is of 5 convolutional layers, followed by pooling. The ReLU activations have 3 fully connected layers. So the rules of the convolutional layers were it detects edges, textures, and shapes in the X-ray images. And layer by layer feature extraction was initial layers focus on simpler edges. Deeper layers capture more complex shapes and indicating potential issues like fluid in the lungs. Our pooling layers where we had max pooling, which reduced dimensionality and computation. It had retained most important features. I prevented overfitting, focused on dominant patterns, ensuring the model was able to generalize well to these new images. The application in ClearScan, it was important for medical imaging. Patterns can be subtle, and the pooling helps retain critical details for accuracy diagnostics. Our activation functions for the ReLU activation, it was a nonlinearity, which allowed the model to learn complex patterns. It was faster in training and more effective than other activation functions, and it was also ideal for neural networks. I use the sigmoid for the outer layer, which produced a probability of 0 to -1. It's easily mapped to binary classification for normal versus pneumonia. For the fully connected layers, it combines features from convolutional layers. Fully connected layers in AlexNet ensuring all learned patterns are considered in decision making. And then the application inside ClearScan converts X-ray features into classification models, which were normal or pneumonia. For the loss function, it was a binary cross entropy, which had measured model performance by comparing the predicted versus actual classifications. It was suitable for binary classification problems and had minimized costs associated with incorrect classifications. We used it because ClearScan models fine-tuned using binary cross entropy and ensured a low false positive rate and a false negative rate. The training evaluation process was on a data set with thousands of X-ray images classified between normal pneumonia through Kaggle. It was the augmentation techniques for rotation and zooming used to enhance the robustness of the actual model. Evaluation on the metrics were precision, recall, F1 score, results that show high accuracy, and then showing ClearScan's ability to assist accurate real-time medical diagnostics. The deployment using Flask is a web-based interface for ClearScan. It allowed healthcare providers to upload X-rays and receive instant responses. The web interface and accessibility ensures easy accessibility from any device, with no special hardware. Integrates with hospital systems, and ClearScan's tech is easily deployable and scalable. Here's our email, website, and LinkedIn. And here's kind of an app layout that I had AI generate just to have a broader idea or better idea of how it would look on your actual mobile versus a web page. Here was the old model results. Obviously, you can see it wasn't great compared to what we have now. Another old model, and then here was the best results that we had. So, yeah, that's it. Thank you.